Section 2.5, ratios, percents, and multiplying and dividing real numbers. So we're going to start out with percentages. I'm not going to do a ton with percentages in this section, just kind of get used to them, see how to convert in and out of percentages, and we'll return to them later and do more with them. That'll be in later chapters. So we're going to start off with the definition of percent, and percent literally means for each hundred or per each hundred. So when you see a percent, you should literally translate it as a divided by or over 100. And if you do that, that would actually help you to see how the conversion works. So let's look at 91%, and they want us to switch back and forth here. If we're in percent, go to decimal and vice versa. So if we just followed this definition, 91% means 91 over 100. And if you were to bring in the calculator and do 91 divided by 100, you get 0.91. And that always works the same way, which is to say that if you divide by 100, the decimal goes from where it was to 2 spots to the left. That's always the case. So let's jump down here to 3.8%. It means 3.8 over 100, but you don't need to pull the calculator in. You just need to move that decimal 2 spots to the left. And the first move would make it go past the 3. When you move it again, there's nothing there. So you have to put a 0 as a placeholder in that spot where the second move would have been. And you can kind of think about if you moved it back, 1, 2, that's where it was before. So you want to make sure you always move it 2 spots because you're dividing by 100, which has these 2 zeros. So it's not move it to the front, it's move it 2 spots. Sometimes that'll be to the front, sometimes not. But you need to move it that many regardless. And then I talked about right here, like to check this, we could just move it back 2 spots, and it turns out that's what you want to do if you want to convert from a decimal to a percent. This one is already a decimal. If you want to make it a percent, imagine moving that 2 spots to the right, which would be 8, and then put the percent symbol back on. 0.089, 2 spots to the right, that would be 8.9, and then put the percent symbol back on. So going from percent to decimal or decimal to percent is always a 2 decimal place move. When you do this one, it's 2 to the left because you're dividing by 100 and the percent symbol goes away. When you're doing the opposite, it's 2 to the right because we have to do the opposite of before, and make sure you put the percent symbol back on there. So here's the book summary of that process. If you're converting from percentages to and from decimal numbers, to write a percentage as a decimal, remove the percent symbol and divide the number by 100, which will have the effect of moving the decimal 2 spots to the left. To write a decimal number as a percentage, you want to multiply by 100 because you want to do the opposite of up above, and that will have the effect of moving the decimal 2 spots to the right, and then make sure you remember to insert the percent symbol. Typically when I do these, I just think about the moving the decimals, and in stat I do this all the time. In fact, mentally it just almost happens automatically for me. When I see 0.08, I kind of think of it as 8%. When I see 3.8%, I'm thinking 0.038. So you want to get really fluent with this moving back and forth. So try and get it to a point where it almost becomes natural. You don't want it to become a pure memory thing though, or it doesn't make sense to you. So remember, the reason we're moving 2 places to the left is because we're dividing by 100. The reason we're dividing by 100 is because it's per cent, like per division, cent like century, 100. All right. Let's see a quick example where we would use this skill. Find 6.4% of 3,500 cars. So what we want to do is just translate this statement. And when we do math with percentages, we tend to make them decimals first. So 6.4%, move that decimal 2 spots to the left. That would be 0.064. And then of means times, and 3,500 cars. I like to use the asterisk for multiplication because if I put a dot right there, it gets confused maybe with the decimal point. This is what calculators and computers do these days, so it kind of makes sense there. And speaking of calculators, I do want to bring it in here. I could do that multiplication by hand, but I don't want to. So 0.064 times, notice it does an asterisk, 3,500, which is 224. You don't have to use the asterisk, but again, if you use the dot, you got to be careful not to mix it up with the decimal. And you could also use parentheses around the 3,500, but I don't really like to use parentheses when they're not absolutely necessary, because I like to think of why I need those parentheses, which we'll talk about more in the next section. And then we should put units on this too. It's 224 what? It was 224 cars. All right, so not much there with percentages, moving in and out of percentage form, and then moving to the decimal form if you're going to do some math with a percentage. And again, we'll come back to that in later chapters. All right, so now we're going to move on to multiplying and dividing real numbers. So what we're talking about there is really knowing the properties of sign numbers when it comes to multiplication and division. So you have -3 times -6. So you just need to know, what do you do when it's a negative times a negative? And I would argue that there's a way to talk about what this means, but ultimately you do need to have this memorized. A negative times a negative is a positive, and 3 times 6 is 18. 35 divided by -5, I like to think of it like this. A positive divided by a negative is going to be negative. And then I have to do the division problem, 35 divided by 5. So I've kind of thought about the sign separately, and now I'm going to do the division. And 5 goes into 35 7 times, and that negative is sitting there. So a positive divided by a negative is a negative, and 35 divided by 5 is 7. So the overall answer, -7. So a negative times a negative will give you a positive answer. And we're seeing over here that if you have a positive number divided by a -1, your answer will be negative. And you do want to remember these sign rules so that they're quick and easy. Make sure when you're doing the MyMathLab on this sort of stuff, you're trying to do it without the calculator and that you're making quick decisions, and keep practicing until you feel really comfortable. So continuing on with some more examples, we have some decimals here. I would argue that as soon as you see decimals, that is permission for me to go ahead and use your calculator. So I'm going to think about the sign rules on my own, though. A positive times a negative should be a negative. And then I just want to know, what is 3.7 times 5.24? I've thought about the sign rule myself. A positive times a negative is a negative. Now I'm just using the calculator to sort out what would be a somewhat messy decimal multiplication. So 19.388. Again, you have a negative divided by a positive. So that answer is going to be negative, and then you can go ahead and use the calculator to do it. 0.12 divided by 0.3 is 0.4, so -0.4. Every circumstance I can think of on MyMathLab where they give you decimals to multiply, divide, add, subtract, you can put a decimal answer. So using your calculator in those situations is fine with me. All right, so let's go ahead and look at some fraction work now. This one can look like a pretty intimidating problem because of the negative signs and the fractions, but just treat it as two separate issues. You have a negative times a negative, which will be positive, and then you just need to work this out as a multiplication. So you think of what's going on with the signs, and then you do the multiplication of the fractions. So the answer is going to be positive. I wrote a positive sign there just as a reminder, but we don't want to keep that in our overall answer. Then just a reminder, we're multiplying straight across, but thinking about reducing as we go along. 7 and 5 are both primes, so we can't do anything with those, so we'll just leave them and connect them by multiplication. But this 5 would cancel a 5 down here, so I want to show that 5 by factoring the 25. This 7 will cancel the 7 down here, so I want to show that 7. And then I can go ahead and cancel the 7, the 5 with one of the 5s, and then multiply the leftovers. So on the bottom we have 5 times 3, which is 15. On the top we have nothing. Remember that there's always a factor of 1 left behind when everything else cancels. Alright, so now we have a negative divided by a positive. The answer will be negative. Just write that negative out front. The first number we leave alone, and then we change the division to multiplication by the reciprocal. Now that it's a multiplication, we're going to multiply across the tops and the bottom. That negative sign is just along for the ride out front. I'm thinking about cancellation. The 5 will go into the 15 3 times. So I'm going to write 5 times 8, and 7 times 5 times 3. So since it's my intention to cancel the 5 with the 5 and the 15, I just want to reveal the 5 and the 15. Again, notice I didn't factor the 8. That's because I was thinking about it. All that goes into 8 is 2. These are odd numbers, so there's no 2's down there. I don't want to waste time factoring if it's not going to help me reduce or cancel. That negative still along for the ride. We have 8 on the numerator, and 7 times 3 is 21 in the denominator. So there's our answer. Okay, moving down. When you have a subtraction, we covered this in the previous section. Subtraction is the same as adding the opposite, so this would become 4 plus the opposite of negative 2, which would be positive 2. So that's just 4 plus 2, or 6. Again, a negative times a negative is positive, so I don't need to write the positive. I've dealt with those signs. This is going to be 10 sevenths times 14 fifteenths. Going to multiply across the top, but thinking about cancellation, that 7 would cancel a 7 that's in the 14. The 10 and the 15 have a 5 in common, so 2 times 5 for the 10, 3 times 5 for the 15. And then I can cancel the 5, cancel the 7, and multiply the leftovers. So 2 times 2 is 4, and just a 3 on the bottom. All right, and final one on this page, we have negative 3/8. And subtracting a negative is the same as adding the opposite. One of the things we want to keep in mind is that idea that the two negative signs, right, make a positive. So those two negatives made that positive. One of the things I like to do when I'm adding fractions and one of them has a negative sign out front is to write that negative in the numerator, so I can really focus on the idea that that negative is part of that fraction. I think it's easier to think about it that way when you write it in the numerator than when it's out front. Now, this is an addition problem at this point, and we don't have a common denominator, so we need one. So I'm going to use the think about it trick. What's the smallest number I can think of that is divisible by 8 and 10? So think of multiples of this, 10, 20, 30, 40. 8 goes into 40. So I'm going to want to multiply top and bottom of this one by 4 to get that 40, and top and bottom of this one by 5 to get that 40. And then we'll just finish it off. Negative 3 times 5 is negative 15 over 40, plus 1 times 4 is 4 over 40. And again, keeping that negative as part of that numerator, so it's negative 15 plus 4 over 40. And it's a negative and a positive, so you do the difference, which is 11. The bigger number is negative, so the negative wins out there, so negative 11 over 40. Kind of a messy one there, and we haven't done this in a while, so I'm going to go ahead and check that on the calculator, just to remind you how to do that. So we put the initial problem in, negative 3/8 minus negative 1/10, and I get negative 0.275, and then take my answer, negative 11 over 40, and I get the same thing. Another thing that just kind of came to mind as we were doing that is the placement of the negative. You can place that negative in the numerator, the denominator, or out front, and it should be considered correct in any of those arrangements, though it is uncommon to leave a negative in the denominator, so I would either leave it out front or up top like I did here. So out front, up top, both perfectly acceptable. Technically, leaving it in the denominator is okay, but people don't usually do that. All right, so just a summary here of what I had mentioned on the last example on the previous page, which is if you have a negative on a fraction, you can leave that negative in the numerator, denominator, or out front, and those are all considered okay. Though I will just mention that this and this are preferred, and this one is not so common. So they're all technically okay, as you can see here, but it's not that common to leave a negative in the denominator, so I would recommend either doing the top or the bottom. All right, you're going to see some problems in MyMathLab that specifically ask you to use the calculator to do a problem, and so you want to make sure you notice that in the directions to save yourself a lot of time, and then you also have to pay attention to the rounding directions and make sure you round to what they want you to round. So these are pretty simple problems to do, and you can go ahead, since they're saying to use the calculator, you can even do the sign part. But I want you to always think about your sign rules. So when you type something like this in, I think that before you press enter, you should be thinking this is a positive divided by a negative, the answer will be negative, so that you're staying sharp on those sign rules. Then they say to round it to 2 decimal places, so 1, 2. And the third one you need to look at to see if it's 5 or higher or 4 or lower. In this case, a 0, so we would round down and stay with the 8. So approximately negative 17.48. When you do round, it does bring in rounding error. I always like to let people know that by putting the approximately equal. Now this problem right here is so important that you notice that they're saying to use a calculator, because the denominators and the numerators are pretty messy numbers here. So if you did this all by hand, it'd be kind of a lengthy problem to do. But they're saying that you can use your calculator, so I would. Though to tell you the truth, I think I would use my head for part of it. Negative times a negative is going to be positive, so I would just leave those off and put 169 divided by 175 times 64 over 71, and just save myself the typing by knowing my sign rules that a negative times a negative is positive. And then round that to 2 decimal places. Again, we have a 0, so we'll round down and stick with the 0.87. So this is approximately 0.87. And I will just point out real quick that if you wanted to keep all those signs there and enter them in, you certainly could. I will just point out real quick that for that negative, I started to hit the subtraction key, and you will get an error if you use a subtraction key in a spot where you're just trying to assign a negative. So be careful with that. If you're just trying to say it's negative, do it that way. Uh-oh, got a different answer. What did I do? 169 over 175 is correct, and 64 over 71 is correct. So did I mess it up the time before? Oh, I put a division this time, sorry. So what I just did there is I hit second enter, and above the enter key it says entry. So that's a nice little trick if you realize you've made a mistake on a lengthy expression. You can pull it up, just change that to a times, press enter, and see the same answer as before with that 0.87. So second enter is a nice trick when you do make a typo to fix it. But notice it was kind of a headache for me to type it in with the negatives. So it's probably better just to use your head and say negative times a negative is a positive and move on. All right, now we're going to wrap this section up with just a little bit of a discussion on ratios. So write the ratio as a fraction. When they say the ratio of 6 to 8, that means 6 over 8 is the way we'll end up reading that. So 6 over 8. And then we simplify ratios just like fractions. So there's a 2 in both the top and the bottom. So I'll show that 2, cancel it, and we're left with 3 over 4. So that's the simplified ratio of 6 to 8. Now there's something they want us to think about in this section called a unit ratio, and that's a ratio where we write it as A over B or A to B, but the B has to be a 1. So I could do that with this one actually in a couple ways. I could write it as 3/4 over 1, or I could write it as 0.75 over 1, which is kind of the more common way to do it. Let me box this answer because that's the answer to that question, but it wasn't a unit ratio because the denominator was 4. When they start asking you for unit ratios, you have to force the denominator to be a 1. So let me show you how that works with this example. A person has credit card balances of negative $68.10 on a Visa and negative $29.50 on a Sears account. Find the unit ratio of the Visa balance to the Sears balance. So Visa to Sears means it's going to be Visa over Sears. So Visa, negative $68.10, over Sears, negative $29.50. Negative times a negative would be a positive. Negative divided by a negative would be a positive. So I'll just go ahead and get rid of those two negatives. And now you could spend a lot of time trying to reduce this and so on, but they want a unit ratio. So if it's going to be a unit ratio, they want the denominator to be 1. So I'm going to go to the calculator and I'm going to figure out what that division is. 6810 divided by 2950. They didn't give rounding directions here. It is money, so I'll just round it to 2 decimal places, 2.3. And then the second is a 0, but it's followed by an 8. Anything 5 or higher in the third place means we need to round up in that second place, so 2.31. I also think it's good to put units on it, so it's $2.31 over $1. And so that's a unit ratio now because the denominator is a 1, and I got there just by doing the division on my calculator and writing that in the numerator and putting the 1 in the bottom. So what are unit ratios good for? There's a couple things. Let's see one of them by answering their question here, and then I'll mention another one. If the person wishes to pay off both accounts gradually in the same amount of time, describe how the result in part A can guide the person in making his next payment. So what we want to do is think about the order here. The top was Visa and the bottom was Sears. So for every $1 they pay on their Sears card, they'd want to pay $2.31 to the Visa if the goal is to pay them off gradually at the same time. So I always like to do my interpretations from the bottom up, and keeping in mind it's Sears on the bottom, Visa on the top. So for every $1 the person sends to the Sears account, they should send $2.31 to Visa. Now, we're definitely not recommending here that the person just send $1 to Sears and $2.31 to Visa. We're saying for every dollar they send to Sears, send $2.31 to Visa. But they should probably send a lot more to Sears if they can, right? Let's say they decided to pay off $57 to Sears. So 57 going to Sears. What should they send to Visa? Well, for every one of these, they should send 2.31. Well, there were 57 of those, so it would be 57 times 2.31, or $131.67. I just made up the 57, but the point is whatever they send to Sears, they should send 2.31 times that much to Visa. So one of the things that a unit ratio gives us is a multiplier. That number in the numerator, 2.31, tells us what to multiply our Sears payment by to get our Visa payment. And that idea of thinking of a unit ratio as a multiplier is going to become very important much later on in the course. All right, that wraps up section 2.5.